expressing a recurring decimal in the form of a fraction, so p over q, that's fraction format, where p and q are elements of integers, so they're positive or negative whole numbers, and they tell me that q cannot equal 0. If you have a 0 in your denominator, it's an undefined number. Okay, right, so the sum to infinity of a geometric series is going to come into play for expressing a fraction as a recurring decimal, or expressing a recurring decimal as a fraction, okay? So first example, if I wanted to express 1.22222, and it goes on forever, in fraction format. Now obviously look, the calculator will do that for me, but it's higher level maths. We have to be able to do it by hand. Now on the calculator, if I was to do it, it's 1.22 recurring decimals, so I'd press 1 point. Now, I know all calculators are slightly different, but you're looking for the box with a little dot in it for the recurring decimal symbol. Now, on this calculator, I have to press Shift and then the little box, and you can see that coming up on my screen. The little dot over the box is the recurring decimal. So if I put 2 in there, press equals, it gives me back what fraction that's equivalent to. So it's 11/9. Okay, 1.22222 goes on forever. All right, so it's that little box that you're looking for on your calculator. Okay, so I know what my answer should be. When I want to write 1.2222 as a fraction, I know it can be written as 11/9, but now I have to do that by hand. Okay, so we need to break up the recurring decimal as the sum of its parts. So I've got one whole unit, then I've got 0.2 as a decimal, which is 2/10. Then you've got 0.02, which would be 2/100. Then you've got 0.002, which would be 2/1000. Then 0.0002, which would be 2 over 10,000. And it'll keep going on in that fashion, okay? It goes on to infinity. Now, you look for where does the pattern start to repeat itself. This is the pattern. The 0.2, the 0.02, the 0.002, and so on. Like, I'll know then what the next term is based on the pattern that I'm seeing. The 1 is separate to the pattern. It doesn't disappear, but it's not going to be part of the series. So the sum of the series will start at 0.2. And it'll go to infinity. Keep the 1 separate for the moment. Okay, so when I'm working with the series, that's the part I'm working with. Keep the 1 separate. So A is the first term in that geometric series, and the common ratio would be 1/10, or 0.1 as a decimal. How did I get that? Term 2 divided by term 1 will give you the ratio. You could go with term 3 divided by term 2, you'll get the common ratio. You could go with term 4 divided by term 3, you'll get the common ratio. So 1/10 is my common ratio, or you could leave it in decimal format, 0.1. Given that it goes on to infinity, I'm now going to use my S of infinity formula. So it'll be 1 plus the S of infinity formula for this series. Okay? So A was the first term in the series, which was 0.2. All over 1 minus the common ratio, so 1 minus 1/10 would give me 9/10. So that's 0.2 divided by 9/10, which gives me 2/9. Now, I'm not finished. That was just the sum of the series part. But if I go back, remember the 1? I now have to add 1 onto the answer I got for the sum of the infinite series. So 1 plus 2/9 gives you the 11/9. And I already knew that's what it should be because I had checked it on the calculator. Okay. So that's what it was on the calculator, and that's what I got when I did it by hand. So I know I'm correct. Here's a second example. If I wanted to express 6.0072, and there's a recurring decimal over the 7 and the 2, I can write that as a fraction as well. Okay, so I can check what it should be on the calculator first. So when I type it into the calculator, again, I'll press 6.00, then I'll press Shift, and I found that little box with the dot on it, and I put in my 7 and my 2. If I press equals, it comes back as 1,652 all over 275 as a top-heavy fraction. So that's the answer I should be getting, and now I'm going to do it by hand. So I'm going to break up the decimal as the sum of its parts. Now, 6.0072 with a recurring decimal means the 7 and the 2 are going to keep repeating themselves. So it would look like this if I was to write it out in full. Right, 6.0072, 72, 72, and it'll go on forever to infinity. So if I break it up as the sum of its parts, you've got 6 whole units plus 0.0072 would be the first part of the pattern. The next one then, it would be the next 72, which will end up being 0.00072. The next 72 will be 0.00000072, and I'm just writing them out as the sum of their parts. The pattern starts to form here at the 0.0072s, okay, and it'll go on to infinity. The 6 is not part of the geometric series, but we don't ignore it either. I'll just bring it down. So this is my geometric series and it goes on to infinity, so I put down my S of infinity formula. A is the first term, 0.0072. To get your common ratio, one term divided by the previous term. So 0.000072 divided by 0.0072 will give me 0.01 as a decimal, or 1 over 100 as a fraction. Okay, so I now have my value for A, which you could write it as a fraction if you want, and my value for R, the common ratio. And I sub into my S of infinity formula. So it's going to be A, which is 72 over 10,000, or 0.0072, all over 1 minus the common ratio. And that will all tidy up eventually down here. As I keep breaking it down, it'll tidy up to be 72 over 9,990. But then I have to add the 6 onto it. The 6 did not disappear. It was part of the number originally. It just wasn't part of the geometric series part. So I add the 6 onto that and I'll get back the top heavy fraction that I originally knew I should get on the calculator. This was just me doing it manually by hand. You can just do it on the calculator. If you throw all of that into your calculator, it will automatically give you back 72 all over 9,900. Alternatively, keep simplifying it, then it's fractions divided by fractions. Leave the first fraction alone, change your sign to multiply and flip the second fraction and simplify above and below where you can. 100 will go into 10,000. It will go in 100 times. Then it'll be top by top, bottom by bottom, and you get your 72 over 9,900 that way as well. Okay, so that's how we write recurring decimals as fractions. And always get used to doing it on the calculator just to see first what should you be getting, because then you'll know whether your answer is right or wrong when you do it out manually. And just make sure you know how to get the recurring decimals and you know how to write it out as the full digit if you had to. Now, you'll never be able to write the full digit because it does go on forever, but you'll write the first few anyway so that you can spot where the pattern starts to form so that you're able to break it up into the sum of its parts.